Okay, good morning or afternoon or night, whatever time it is you're watching this. This is the first class of Unit 3, and today we're going to cover the parabola and the circle. And this topic...
Black was the first color that you...
Why is Google always listening? So this topic, it says here plane analytic geometry. Really what it is, and when we talk about this, when I talk about this, I'm going to be talking about something called conic sections, or sections of a cone, technically sections of two cones. So all the shapes we're going to come up with, because this whole unit's about shapes. So if you like geometry, you'll probably like this unit quite a bit. Because all of the shapes we'll make in this unit are based on what you would get if you cut cones using what's called a plane, or just a... So for example, we're going to have, today we're going to be working on parabolas. And so you notice it has this shape, which we've seen before. It's as if you cut a cone down the side here. Or later on today, we're going to look at circles. This is not a top-down view, but if this was looking straight down on the cone, straight down like that, you would see it was a perfect circle. If you turn that on the side a little bit, you get an ellipse. And if you put it straight up, you get what's called a hyperbola, because you've cut a cone twice. Maybe this is a little more clear. You can take one cone and slice it in different ways. This is, of course, 3D. And you get 4 different shapes: circles, ellipses, parabolas, and hyperbolas. Today, we're doing parabolas and circles. And that might seem like a lot of work, but once we get into it, I think you'll see it's actually not too complicated. So hello to everybody who just came in. Hamza and Khalid. Nice to see you. I was just doing a brief introduction. So let's get right into it, because like I said, lots to cover today. The first thing, let's do the first things first, the parabola. Well, I don't think any of you have had time to watch Tom's videos. If you have, that's great, because he summarized everything. But I'll try to focus on the key points. Parabola is what we've seen before, these curvy lines, smiley face, sad face, and so on. Set of coplanar or points, which are equidistant from a given line and a given focus, or a given point called a focus. So let me get right into it. There are 3 pieces of a parabola that are the pieces of information you need to know, and if you know them, you can build the parabola. For example, let me be more specific. The focus, the directrix, and the vertex. I don't really need the, so it's focus, directrix, and vertex. Those are 3 things that, if you know them, completely describe a parabola. And let me go into what they are. First of all, the vertex I would like to start with. The vertex we kind of already know, or you might already know, is the maximum or minimum point of the curve. So we can see that the vertex, let me just draw another sketch here. The vertex of this parabola would be right here. And the form, we'll say, of this would be x squared form. And we know that from before. Y equals x squared looks like that. That's the vertex. I'll label it V. There's 2 more things you can see here that are new to us. The first one is called the focus. The focus is just a point inside the parabola. I'll make it a slightly different blue. That's our focus. You'll notice it's inside the curve. And the reason it's inside the curve, and the reason it's called focus, is if you were to shine light inside this parabola, all the light, no matter what you sent in, would actually, it would always bounce back and land at the focus. It would bounce into that. So that's why it's called the focus. You don't obviously need to worry about that. We're not going to be doing a lot on that idea, but that's why it's called the focus. And finally, there's what's called the directrix, which is a line on the other side of the parabola. And the vertex and the focus are equidistant from the vertex is the same distance away from the directrix, and the vertex is the same distance away from the focus. And the distance there is what we call P. Now this probably seems like a lot to start with, but there's only a few concepts we really need to worry about. So you'll see I already covered all 3 things that describe a parabola. The focus, which is a point p units from the vertex that's inside the parabola. You'll have the directrix, which is a point p units from the vertex on the other side, perpendicular to the axis of symmetry. The axis of symmetry is going down straight through like this. And the vertex, of course, is that maximum minimum point. So before I go any further, this p-value is just like a distance from the vertex. And we see this as x squared form, but there are other types. There are other forms we could have. That's what we would call like a positive x squared form. It has a positive p. Another type we could have is x squared form, but of course it could be upside down. And we have the same things. We have the vertex here. Where does the focus go? The focus goes inside, like this. The directrix goes on the other side, like this. And the distance that they are from each other is the p-value we're talking about. It's just the distance. It could be positive or negative, but really all that you need to think about is you're adding it or subtracting it depending on where you are on the vertex. And this would be our negative p-value, which we'll see later, okay? There are two other ways we could move this curve. We can move it so it opens to the side that way or opens to the side this way. So I'm going to draw these. I recommend that you also draw them. They're just sketches. Let's say we have a curve going like this. This would be y squared form, positive p. Just think of yourself, instead of, remember our positive before, let me make this clear. Remember we had something like y equals 5x squared. That was a positive 5 in front, so it opened upwards. That's like our p-value is positive, like our a value before. Well, when we turn this sideways, we might have something like x equals 5y squared. So instead of opening this way on the positive y-axis, we just turn, and now we're opening this way on the positive x-axis. But everything else is the same. So we can mention where the vertex is. The vertex is right here, V. We can mention where the focus is. It's inside, F. And we know where the directrix is. It's on the other side of the vertex. And it's equidistant. It's the same distance to the vertex from the directrix as it is from the vertex to the focus. And that's, once again, the distance here is P. Finally, you could probably imagine what I'm going to do next. I'm going to move the vertex, sorry, I'm going to move the parabola this way, and we can label it again with the focus inside, the vertex at the maximum or minimum point, the tip there, and then the directrix equal distance away. And this is also y squared form, but it has a negative p-value, which again, I'll cover that more in detail in a little bit. So these are our big ideas. Let me label them. V, focus, and then directrix. This line would be x equals some constant, which I'll cover later. That's our directrix though. Okay, so it helps to see some examples on this, which I'll get to. I'll just show you one last picture. Notice what the focus does. If you have your focus right here, that's a bad example. If you have your focus here or here or here, if you were to shine light inside this parabola, I know I have another couple shapes here, but if we just look at the parabola, you shine light inside and it goes, it would go right to the focus. There's a few other things I could bring up there, but these are the main things if we're actually going to do this topic. So sorry to talk your ear off, but it's important to set this topic up, and it'll set you up for success a little later. What about equations? Well, all the basic equations are laid out here. You can see this equation is obviously going to be important. All equations are that we do. And this equation. And they look complicated, but they're really not. We've actually seen most of them before. We can call this y squared form. I hope you can notice why. It's because this y term here is what has the square on it. And this other one over here is called x squared form. For the same reason, it's the x stuff that has the square on it. And we have this h and k again. but we saw H and K before, or a version of it. It's like a translation. So the vertex is just going to be H and K. Whatever number we have here, we just change the sign, that's our H value. Whatever we have here next to the Y, we just change the sign, that's our K value. Another way you can think of it is that if you have H minus K, you just set it equal to 0, and then that will give you different ways to think of it, but we'll work all the way through it today. And again, all of our basics, if P is positive, it opens right. If it's negative, it opens left. On the other case, if it's positive, it opens up. If it's negative, it opens down. But the best way to understand this stuff is through an example. So let me move on to an example so you don't fall completely asleep. All of those examples were done by Tom. So let's get awake here. The question says, find the coordinates of the focus, the vertex, and the equation of the directrix. You'll notice that the directrix is actually an equation. I'll get to that more in a second. For each parabola, and sketch each parabola. Super, super, super important that we sketch here. If you don't have the notes in front of you printed, you should definitely have a piece of graph paper by now, but you'll see that you can sketch it even without any of those things. Okay, so let's get started. First of all, I look at this equation, I'm looking at C, okay? What form is this in? Is it in x squared form or is it in y squared form? Well, we can see here that it's in y squared form. That means it'll open left or right. Which way does it open? This 4 tells us about our p value. We know it's positive. So let me color code it. This is a positive number. You can see that this is y squared form. That was positive. Positive p means that it opens to the right. Opens to the right. So I'm going to make a little sketch. First of all, what do I know about this? I know that it's going to open to the right. That's about all I know. I can also get my vertex. My vertex. Vertex is given by this and this. Just change the signs. 2 and negative 1. Notice that it's y minus 2. Oops, I made a mistake. Of course, the one next to the x needs to be the x value. So negative 1 and positive 2. Just change the signs. Now we can sketch that. Negative 1 and 2, well, I need to go 1 left and up 2. I'll put a little note there. You absolutely should sketch this. Most of what we do in this unit, if you don't sketch it, it'll be way, way harder. So we'll always start with the y and x axis and then put our point, our vertex. Now, just by looking at the equation, I know it's y squared form, not x squared form. So it opens this way. There's the positive value in front of that linear term, x. And so it opens to the right. I'll just make it open to the right here. I know somewhere inside of that, I'm going to have a focus, and somewhere on the other side of it, I'm going to have a directrix. So first of all, maybe if you remember earlier, I'll just rewrite it here. Our form is y minus h squared equals 4p x minus, oops, I got my h and k backwards. Y minus k. So what you'll notice here is that 4p is what's in front of the x term here, and we have a 4 here. So more specifically, that means that 4p must be equal to 4 in this particular case. You'll notice that they're related here. Let me just connect them. 4p equals 4 because of the way that these equations match. That means that p must be equal to 1. That's now our distance from the vertex. I'll write this down. This is the distance from the vertex to the focus, and also the vertex to the directrix. Okay, so let's go look at our vertex here. It's up on the graph. That's our vertex. I'll label it just the first time around. Our vertex here is -1 and 2. You can see that. The focus must be one point or one block away from the vertex. So this is the first question I'll actually ask you. What coordinate is the focus at? Remember, it's got to be a distance of 1 away from the vertex. The focus is inside. If it's that far away, it means that it must be moving on the x direction. What's our coordinate going to be? Anyone have any ideas? Are you totally lost? I'll give it to you. So we know that it's a distance 1 from the vertex, and so it must move over 1 and be over here. So the focus must be 0 and 2. It's shifted by 1 to the right inside the parabola, and so now the point is at 0 and 2. The directrix is on the other side. We'll sketch it here. The directrix is here. That is an equation, and when you have equations of lines, you must either have y equals something or x equals something. Well, this is just like we had our axis of symmetry before with x symmetry, we need to use y values. In this case, we would have y symmetry, we use x values. Or in other words, every point on this line has a value of -2. No matter where you are, you could be right here, that would have a value of x equals -2, x equals -2, x equals -2, x equals -2, x equals -2. Every point on that line has a value of x equals -2. So that's the actual line, x equals -2. So let me fully write out everything that I have. Focus, what's the actual coordinates? It's 0 and 2, and the focus is a point. The directrix is a line, and the line is x equals -2. The directrix will have the same letter as our term that touches p in our equation. So I don't know if anyone's awake or alive out there. Maybe you're all studying for your assignment. Hopefully you're paying attention because this isn't obvious the first time around, although all of the examples are very similar to each other. So honestly, if you understand clearly all of these concepts now, you can actually do pages worth of examples. I don't expect that all of you can do that yet, but I hope you're at least paying attention. So D, I would like you to try, but I'll do it partly with you. So let me step you through it. First of all, can someone tell me if this is x squared form or y squared form? In question D. Hamza, Jassim, Kevin, Khalid, Hassan. I know someone out there can help me out here. Or Zada, I didn't even see you. Hi, Zada. Someone tell me if the term that's squared has an x in it or a y in it. Yes, thank you, Kevin. I was actually worried that my microphone wasn't working or there was something wrong with the internet. Yes, it's x squared form. Absolutely, it's x squared form. So we need two pieces of information at once. It's like we did before. Look, x squared form because it has an x and a square there. That's x squared form. And we look in front of the y term, the linear form. We know that that's a negative. So we are going to say it opens down. If you wanted to sketch this, you would just say it looks like this. Okay, and we can put our focus down inside of it. We can put our directrix on the other side of it and so on. But it's going to look something like this. Like obviously that's a sketch, but it should look like that. Okay, we pulled that just from the equation. Now that we know that, we can immediately get the vertex as well. Vertex. We don't even actually didn't even need to know any of that to get the vertex. Just look at the x. It has x plus 1. So that means that our x value is actually -1. We just change the sign. Or remember, if you want to, you can say x plus 1, set that bracket equal to 0, and solve for it. It means x is -1. The vertex value, the x coordinate of the vertex, is -1. And do the same thing for y. You change the sign, it's 4. So our sketch, I'll start sketching. Our sketch will have -1 and 1, 2, 3, 4. It will have a vertex at -1 and 4. That'll be our vertex, and it's going to open down. Okay. So this is a good start. There's obviously more things we need. I know that because if I scroll back up, first of all, I need the focus, vertex, and the equation of the directrix. Sorry, I thought it was just equation there. Or if you go back to the page 2 pages ago, this is the 3 important things: focus, directrix, and vertex. We're always looking for the 3 things. Those 3 things fully describe our curve. So let's keep going here. We can get P from this. We can see that there's a -4 here in front of the y term. That must be our 4P. So 4P equals -4. You're not sure where the -4 came from. It's this. That's our 4P. And solve for that. So divide both sides by 4, get -1. Or just 1. It's a distance, so honestly the sign doesn't matter very much. What it means is that we're going to have our focus 1 away from the vertex in the y direction. So that means if we open downward, let me just sketch this, we're opening downward. Our focus is 1 point away. Again, don't really care about the negative, we just care that it's away from it. So move 1 point down. It's right there. That's our focus. What's our coordinates? Focus must have the coordinates. The sketch is helping me. It had the same x value, so -1, but it was 1 down from where the vertex was, so 3. So really, the only difference here, we've had to change the 3. What's the directrix going to do? The directrix is 1 point above the vertex. Remember, the focus and the directrix are the same distance apart from the vertex, and it's by the value of p. So the distance is p, or 1. So the directrix, in this case, it's a flat line like this, but I said it has the same equation letter as the one touching p. So it's y equals, and they all have a y value of 5. So I think that's everything. I think we fully described this parabola. We've drawn the parabola, it opens down, we have the vertex labeled, we have a focus labeled, we have the directrix. I could even label the directrix here, y equals 5, if I wanted to. But this is how we sketch parabolas. Okay? Hopefully that makes some sort of sense to you. The rest are very similar. E and F are very similar. I would like you to try one of these because we have lots to cover today, of course. I'd like you to try, let's see, F looks almost exactly like the previous one. Just try E. Take 2 minutes, so until 9:27, and try E, okay? I want you to tell me what the coordinates of the vertex focus are, and tell me the equation for the directrix. Okay, give it a Is anyone trying it, or are you stuck? If you're just stuck and you want me to do it for you, I'll do that, of course. It's not quite in 2 minutes, but I want to continue because I have lots to cover still. And of course, I want to give you time for the assignment starting at 10 o'clock. Okay, so let's go through the exact same steps I did before. Hopefully you're following along. First things first, get the vertex. The vertex is very clear from the question itself. The number next to the x, which in this case is x minus 2, just change it to a positive in this case. Change the sign, it's now a 2. And then the y plus 5, change it to a minus 5. That's our vertex, to a negative 5. So I can right away sketch this. I can go 2 to the right and down 5, 1, 2, 3, 4, 5. And I have a point here. That's my vertex. Okay, next thing, I need to get my p-value. My p-value in this case, for p equals whatever's in front of the linear term, in this case, negative 8. Negative 8. So you can actually just divide it by 4 every time. So what's negative 8 divided by 4? Negative 2. Or 2, it's a distance. So I need to go 2 to the left to get my focus. How do I know that? Well, because from the very beginning of this question, I knew that it opened left. And now I just go 2 to the left to write my focus. That's my focus. I should write down the coordinates. So the focus, it clearly went left, so it affects the x value. It must be at 0. And then negative 5 stays the same. It's the 0 that I changed. Okay. The directrix is on the very other side of the vertex. So I just need to go 2 more over. 1, 2. That's good enough. You should use a ruler for this, but that's my directrix. I know it has the same letter as the one that touches P. So this is actually always has x values of 1, 2, 3, 4. So the directrix must be x equals 4. And I have everything I need. I have my vertex, I have my focus, and I have my directrix. There's only 3 pieces really that describe the parabola. Everything else in the middle is just ways to get it. So let me summarize it. First things first, get the vertex, take it directly from the equation. If you want to know if it's going to open up, down, left, or right, y squared form, it goes this way. If it's x squared form, it opens up and down like we're used to. You know, y equals x squared, you know what that looks like. If it's a negative p-value, it opens down or left. If it's a positive p-value, it opens up or right. And then add all those ideas together and get your shapes out of this. Honestly, it's actually not very difficult. It might seem like a lot of work, but it's actually only 3 steps. Okay, so everything else I'll allow you to do for homework. Again, you might need it now that if you've been studying for your assignment a lot, but I've covered pretty much everything in that topic. So do you have any quick questions before I move on to the next style of parabola question? Some of you, I think, are just joining us, so hi. Going once, going twice. Nope. Okay, so you've got lots of examples here. I've done 3. Tom did 4, so you have more than enough if you want to go back and review it. So graphing them. In order to graph a parabola, we need to determine which direction the parabola opens and find the following important points: vertex, focus, directrix, and then the 4th part here says a couple other points. So it just means determine where the 3 most important pieces are, and then use your extra points to figure out how wide or how big the parabola is. So let's go ahead and take a look at this example in practice 2. In this case, it says graph each parabola for the given equation. So right away, I see that it's clearly x squared form, and I see that this is a positive number, so I know it's going to open up. It's going to look like this. That means that the focus is inside and the directrix will be on the other side. So right now I know a ton about this. In fact, there's also a very easy way to figure out what the vertex is. There's no H or K touching X or Y. So in this case, I know my vertex is 0, 0. Vertex is just 0, 0, because there are no H and K. In fact, I'm going to put that right into my table, and I'm going to put my vertex right here in the center. Now, if you don't have the notebook, or if you don't have these printed, use a sheet of graph paper, get it at Carrefour or something, or use a notebook if you need to, but you got to be sketching this stuff. That's our vertex. I'll even write it here, vertex. How am I going to choose another 2 points? Well, it doesn't really matter what other points you choose. You just need to go left and right. There are 2 birds hanging out of my window. Get out of here, distracting birds. What points do you want to choose? Do you want to go 1 to the left and 1 to the right? It might be a little tiny graph. 2 might work, 3 might work, 4 might work. I'm just going to put in, let's just put in 4 to the right. So I'll go over 4 and check what the y value is. And because this is symmetrical, because it's going to open like this, it's obviously the same on the left as the right, I'll go 4 to the left as well. But you can choose whatever points make sense to you. If you put that in, put x squared in, sorry, put 4 in for x squared, just write it to the side. This would be 4 squared equals 4y. That's 16 equals 4y. The y value must be 4. So it looks like I get a 4 out of this. And then -4, this is symmetrical, so I get 2 and 1. This will always be the case. They're always the same because of the way that the graph works. What do we need now? We need the focus and the directrix. Well, okay. We know that 4p equals whatever this number is. So 4, that means p is 1. And the focus, because it opens up, it's going to go up from where the vertex is. So in this case, the focus goes up from the vertex. Up is y values, so up by 1. The directrix I can get right away. The directrix is on the other side, 0, -1. Now I know I'm going through this fast, but you've got tons and tons of reference material now. So let me go a little slower when I plot these points. First of all, maybe you didn't know about the focus the way that I got it. So I'll plot the points first. Let's see, 0, 0, 4 and 4, 1, 2, 3, 4, 1, 2, 3, 4 and 4. Then -4, 1, 2, 3, 4, 1, 2, 3, 4 up. So my graph should look like this. So you can sketch it. Doesn't need to be perfect. This is obviously not a perfect graph by any stretch of the imagination, but it's good enough. Where is the focus? If I hadn't done this yet, where's the focus? It must be inside the curve. Remember, if we shine a light down into this, it'll converge in somewhere inside. It'll be at 0, 1. I know it's 0, 1 because it's a distance of p away from the vertex, and in this case, p is 1. So I just go up by 1 here. That's the point 0, 1. And then the directrix, should use a ruler for this. The directrix is a distance of 1 away from the vertex on the other side. So the line is y equals -1. I messed up the vertex there. The directrix, sorry, should always be an equation. The directrix is always an equation, so I should have saw that right away, and I made a small mistake there. But this is it. We've graphed this parabola now. You'll notice I have the same main 3 pieces: vertex, focus, directrix. Those are the key pieces we need in order to graph a parabola. The only other thing I did was I filled in the table of values a little bit to figure out how big it was. Like how maybe it's massive, maybe it's really shallow, or maybe it's super stretched out and tall. That's why we put in a couple values. And honestly, you can put in any values that you want. use the vertex and put in any other x value and check it and see what you get. So hopefully that's okay. You guys are pretty quiet today. It's okay, you just had a weekend. It's early for some of you, but hopefully you're paying attention. I want to do B. B is a little more involved, but I wouldn't call it more difficult. If you want me to go back to this, let me know. Okay, I'm going to let you help me through this a little bit. I'll talk you through the process. What does this graph look like? First of all, is it y squared form or x squared form? Which one has the square? Y squared form. Perfect, perfect, perfect. Thank you, thank you, thank you. This is y squared form. That means it either opens that way or this way. You know, it has to do with x's. It's all backwards, right? Y squared form. And the p here, the p value is going to be negative. It means it opens left. So it should look like this. And right away, that tells us that the focus is going to be inside and the directrix would be on the other side. You can pull the vertex from the graph itself, or sorry, from the equation itself. What's the vertex going to be? The vertex, I can clearly see it. It's going to have to do with these two things. Just change the one next to the x to a negative, -3. Change the one next to the y to a positive, +2. And there we got it. Once again, if you want to know another way to do it, just take the brackets, set it equal to 0, and it proves to you that the x value needs to be -3. So that's why we put it into the vertex over here. Okay. So that's our vertex. I can draw that right away. It goes right here. It's our vertex. We know it's going to open to the left. Let me write in -3 and 2. That's our vertex. We know it's going to open to the left. So I should actually be checking, you know, if it's going to look like this, don't draw this. If it's going to look like that, I can't put in x values. I should be putting in y values. It makes more sense into the table of values. So a couple up and a couple down to see what I'm going to get here. So let's just, I don't know, what value should I check for a y value? No, it's already at 2. Should I check 3? No, it's a little too close. Should I check 4? It's a little too close. Just give me a number between, I don't know, 2 and 10. 4. Okay, I'll get 4. That means I'm going to be checking, you know, what's the y value over here? Sorry, what's the x value over there? And then because this is symmetrical, that I went up by 2 from this. You know, I'm going to check the 4 here. I'm going to go down by 2, so I should actually check the 0 as well. It's just up by 2, down by 2. So up by 2, down by 2. And let me be clear, you could choose any. Some are better than others. Some will give fractions. I think this will give a fraction now. But whatever, who cares? No big deal. So let's just go ahead and check it. So we know that we have y minus 2 squared. So I'll put in 4. 4 minus 2 squared equals -12 x plus 3. We need to solve for that. Where did I get this from? Well, let me show you. This 4 is this 4. I'm just solving to see what the related x value is. This takes a little bit of time, but not too much. That gives a 4. This is -12x minus 36. Rearrange that, so that's 12x equals -36 minus 4. So 12x equals -40. That means that x would be, what's 40 divided by 12? That's -3.33. So not the greatest value, but I am glad that you gave me one, Kevin. Nothing wrong with that. That means that our value is going to be -3.33 and 4. Again, the 4 that I'm talking about was in the table. So that would be -3.33. That is about right there. Maybe next time I would go a little further away, but not a big deal. And then because this is symmetrical, we get the other one for free. The other one is also negative 3.33. Just instead of going up, we go down, still 3.33. So our graph looks like this. You should, by the way, you should definitely just sketch this on Desmos. It will help you a lot of the way. But this is what our graph looks like. That's what we got from our table of values. We need two more things. We only have our vertex right now. Second thing, we need our focus, but that's very easy. Well, let me make it this blue. Focus. We know, oh, we don't have P yet. We don't have P. So get the P value. We know that 4P is equal to negative 12 here. Is going to go based on this. Just divide the negative 12 by 4. It's negative 3. So we go 3. The focus needs to be in here somewhere. So we go left by 3, or go inside by 3. 1, 2, 3. We should have a point right there. That's our focus. That's our focus. This is our vertex. Our directrix will be on the other side of the vertex. 1, 2, 3. So our directrix is actually, looks like it's just the y-axis. That means the directrix is x equals 0. And we're good. Let me fill in what I have here. Focus must be, let's see, the vertex is at negative 3, 2, so negative 6, 2. Again, same y value, but moved over by 3. Directrix, x equals 0. So for some of you, this might be a little bit confusing, and I think it will be in the beginning until you do all the practice. But let me try to summarize the main pieces again. The first thing you do, tell me the form, y squared or x squared. If it's y squared, in this case, it'll open to the sides this way. And you look at the p-value, in this case it was negative, that means it opens to the left. Now that you know that, you have a general idea of what this should look like. You should notice that this looks a whole lot like this. I already knew ahead of time what it had to look like. Tell me what the vertex is. Just look at your equation and say, oh, this is my x value, this is my y value. Got it? Put it on the point, put it on the plot. The next thing you do is just check a few points. Like Kevin gave me a 4, check that point, check the other side, and put those in, find the x and y values. But really the main things are the vertex, which we just got, the focus, which you get by getting your p-value. So get the p-value and then just go that far away from the vertex. Let me be clear here. This distance here is just p. So just take it and shift it left by p. And then this distance is also p. So just take your vertex and shift it right by p. And then you have your 3 pieces, vertex, focus, and directrix. All right? Hopefully that makes some sense to you. If it doesn't, I'm very sorry, but there's loads and loads of videos, loads of examples now that we've done through Tom and myself. Okay, is there anything I can review before I move on? You're gonna have not quite a lot of time to practice today. It's gonna be mostly lecture. Now, is that at least partially clear? Maybe you're studying for your assignment, I don't know. I'll take that as a yes. Once again, I wish there was a typing, Ali is typing, but there isn't. I'll just move on. C and D, you can do yourself for homework. There's nothing really special about them. They're basically the same concept, so just try it yourself. And then the final thing we're going to do for parabolas is actually finding the equation of a parabola. And this one's quite simple. You actually don't really need to sketch too much. You just look at what you've been given and follow 3 steps and write the equation based on those 3 steps. So the 3 steps are, first, determine the form. That'll tell you which equation you're going to have to use. If you're going to have to use, for example, a y minus k and x minus h form, That would be the first type. Or maybe you'll have to do an x minus h squared and a y minus k form. That would be the other form, possible form that you could use. And I've written them here. You know, they're the same ones that I wrote up earlier in the notes. And then finally, or the second step, determine the vertex and the p-value together, and then write the equation. The three things you really need are the vertex, the focus, and the directrix. So the examples were done. Let me jump ahead to the practice problems. I need to write the equation of the parabola graph below. So first things first, let's figure out what form it has. I know that it opens down. I can see that based on the graph. It's clearly opening down. So that means that it must have a x squared form. And if you want to know the full equation, it looks like this. I know it opens down, which means that this p-value needs to be negative. Okay, there's going to be a negative there when I finish. What are the three things I need? I need the vertex, the focus, and the directrix. So first things first, let's get the vertex. I can read it off the graph. Vertex is right here. It's the tip of the curve. So read the coordinates. I can see here it is -1 and 1. -1 and 1. Second step, what do I need to do? I think I need to get the value of p, right? I wrote that above. Vertex and the p-value. So let's go ahead and get the p-value. I know that looking at this graph, I can see that the distance from the vertex to the focus is 1. So p equals 1. Okay. P is negative. I can see that ahead of time. I saw that in the original part of the question, so I'll just stick a negative on top of that. And then I'm pretty much done. That's enough for the equation because look, x, let me make this blue so you can keep track of it later. This is going to be x, and then -4, I'm just writing out part of my equation here. I need my vertex things here. So I already have the vertex. I just changed the signs back. It's +1, -1. That's from this. Again, just changing the signs. And then our p-value is -1. So if I put in a -1 here, that's the same as -4 overall. So we have -4. And that's our final answer. So the third step was to write the equation. So let me summarize it using these steps that I said we were going to take. First, decide which equation to use, because, like based on the form. X squared form, got it. Opens down, I can see it opens down. So the negative. The next step would be to find the vertex and find the p-value. So the vertex I stole straight from the graph, and the p-value, I can see that the distance between the vertex and the focus is just 1. So it's 1. I just put a negative in there because I can notice here that it's opening downwards. And then you write the equation. You have the x, it's just general, you keep it x. +1 comes from the vertex here. The -4, that's because it's 4 times p, which is -1. And then you have the other part of the vertex, it's just this. So honestly, there's not a lot to this. Again, it might seem like a lot the first few times around, but it's not too bad. And again, you have lots of opportunity for you to watch the video and make sure you know what's going on here. So second step here, write the equation for the parabola with a focus at -4, -4, and a directrix at y equals -2. So I'll do one more example here, and we'll see how it goes. Write the equation for the parabola with a focus at 4, 4. Well, first of all, the focus is 4, -4. Directrix, y equals -2. So I'm going to make a little sketch. My focus is at -4 and 4. 1, 2, 3, 4. 1, 2, 3, 4. So my focus is here. And my directrix is at -2. So my directrix is y equals -2. That's this. And my parabola must be halfway in between that. So my vertex must be right here. And it must open down because of the way that the geometry works. The focus is inside the parabola. The directrix is on the other side. So I should be able to get the vertex just straight from my graph. You can see that. The vertex here must be, oops, vertex must be -4, -3. Ah, I messed this question up. I went backwards. 4 and -4. Sorry, everybody. Let me try it again. 4 and -4, not -4 and 4. 1, 2, 3, 4. 1, 2, 3, 4. Put my focus there. My directrix is still at y equals -2. And I need to go halfway in between to get my vertex. My vertex is halfway in between right here. That means I need to open downward. The vertex is at 4, -3. You can see I'm thinking through this because some of these, it just takes some logic. You need to take your time, think about what you know or what you will know once you review this stuff well, and you should be okay. So our vertex is at 4, -3. We already have the focus and the directrix. Maybe we can write the formula already because we know what the p-value is. P-value is -1. 1 because we know it's the distance here is p equals 1. And negative because it opens downwards. So -1. Now we have enough to write the equation. This is clearly x squared form and it opens down. So I'm going to write our x squared form. This equals 4 times something, y, x. I need to take away my vertex. So I have -4 and +3. My p is -1, so multiply it by this. What's 4 times -1? It's -4. And that looks like I'm done. So again, these are a bit puzzly, but we're only trying to work out 3 different things: the vertex, focus, and directrix. The p-value comes from knowing the distance between the vertex and the focus, and the directrix is basically the same thing. It's just on the other side of the vertex. Okay, so again, Tom's videos go through a lot of these examples. I also have now gone through a bunch of examples. Normally, I would have you talk back with me, but once you review this yourself, I think you'll find it's okay. The reason I went through this so quickly, there's 2 reasons. First, we have an assignment today. But the second thing is the other topics, ellipses and hyperbolas, are more complicated. So I wanted to just make sure I have enough time to cover those in a lot of detail. The parabola stuff, I think once you actually do examples, you find it okay. There's a million people coming in and out. I hope you guys are doing okay. I just want to quickly introduce the very last topic. All of this, the rest of this you can do for homework because they're all basically the same. The very last thing I want to mention is we're going to cover the circle. And the circle equation we'll see is this. All right? This is what we're going to be dealing with tomorrow. This is our equation. You'll notice that circles don't have a vertex. Circles have a center. And our center here is given by HK. You can see that it's written right here. The center is HK, the radius is R. Just by giving the equation, we can see we're given pretty much how to make a circle. Let me show you something. For example, you're given the equation x minus 2 squared plus y minus 4, or plus 4 squared equals 16. You could tell me what the center of the circle is and what the radius of the circle is. You could tell me from this, h must be 2. From this, you can tell me k is negative 4, because again, you just change the values. And from this, you know that r squared is 16. So what's the square root of 16? It's 4. So I've told you that I have a circle whose center is at 2, negative 4, and its radius is 4. So if I was to sketch this, go over by 2, down 4, 3, 4, that's my center. And my radius is 4 in all directions. Right, so it just kind of looks like this. I'll start again from the very beginning on circles tomorrow, but I just wanted to introduce you to the topic so you have it rumbling around in the back of your head somewhere. Okay, so that's the big idea. Actually, I'll keep that there for now, but maybe I'll redo it tomorrow, okay? Okay, so we have 2 minutes. The assignment will be on D2L. It already is on D2L. It'll open at 10 o'clock. Just go to the Dropbox. I can probably stop this recording. Okay, bye-bye, everybody. Nice to see you.